Welcome, Stefan.
Thank you very much, Dirk. So we spent the next 45 minutes about talking about next generation solutions built on Neo4j. So you have already seen great examples what is already done, and what I would like to do basically the next 45 minutes is just bringing together once more kind of what is the value add, what do we help you basically building solutions on, and why it is a good choice to build on Neo4j, right? So as the agenda, I have prepared, first of all, kind of a general, what are solutions using Neo4j, what is the value add. Then I will drill down a little bit into fraud, more generically, not just insurance fraud, but more generically, talking about GDPR compliance, and then finally, of course, going to some conclusions. Solutions, right? I mean, the question is a new mindset really required for solutions from yesterday to today? What we have seen in solutions, in the solutions area yesterday, basically, is they were basically built for static applications. So it was defined, something was built, and this was something which was simply thought and intended to fulfill current requirements, right? It had performance constraints, and most of the times there was kind of this Chinese wall between the domain experts, the ones who know the business, and the IT experts, right? But what I think we need tomorrow is flexible applications. So they are designed to fulfill not only today's, but also tomorrow's requirements. The performance is not a limiting factor anymore, and the domain experts need to work hand in hand with IT experts. So it's a collaboration. That's actually exactly what we have seen as an example with the presentation with Daimler and with the presentation with Generali, where you also have seen on stage basically people who are on one side from the business side coming and on the other side from the IT side coming. So the evolution using Neo4j, what is that, right? I mean, we have started as a database company, and as you have seen this morning, it basically developed and it evolved into Neo4j platform, adding a lot of components like ETL, adding visualization, adding graph algorithms. And together with third-party tools, this builds up to what I would define as the graph advantage, right? It's an advantage that you can now build your application using graphs, and you can use all the nice technology and all the algorithms graphs are bringing with it, right? Together with domain know-how, together with professional services packages, with system integrators, with partners, what you can then build is basically a graph-based solution, right? I mean, of course, there's also third-party tools. There's all kind of other tools on top of it, right? But what is the value of it? Why would you do it, right? It basically enables you to build solutions which are on one side agile. So you have also seen that and heard that in the last 3 presentations. It's an agile solution you can build, so it will evolve. You can basically build it use case by use case by use case. There's not this big thing you need to define in the beginning, and then it's just about this, right? It's agile. It's also intuitive, so the business people can talk with the IT people. It's high performance to support connected data scenarios. It takes advantage of the connections within the data, and is scalable on traversing through the connected data. As you have seen, and as you will see then in the next couple of presentations, performance is really not a limiting factor anymore. If you look at this data, right, I mean, what do you see? And I give you 3 seconds now, right? Is there a connection from A to R? 1, 2, 3, somebody sees it, right? All right, so now you need to swap your glasses, right? Because what you want to do is basically to bring in something which helps you really to understand what these connections are about, right? And if you have now your glasses on, and if you look at this one, is there a connection from A to R? And if I give you now also 3 seconds, I think most of you, if you have real glasses on at least, right? Some of you may see that there is a connection from A to R, right? And that's what it is about, right? It is about enabling you to see the connections and to find the connection and take advantage of them. So graph-based solutions, right? I mean, if we take just a couple of them, right? So they might be telco OSS, telco BSS, they might be fraud solutions, they might be MDM recommendations, whatsoever, right? GDPR. So what are key features if you build them on a graph? The key features are on one side speed, so they are real-time query enabled. So it is not about batch processing anymore. It's about real-time capabilities. You can provide a 360-degree view on data. You use the data connections as a value. They are intuitive, they support the business needs, and everybody can talk about the business needs, and they are flexible, and they're resource efficient, right? I mean, you may have seen, or you may have heard that, right? If you compare basically apples to apples, and you take an application built on a graph database, Neo4j, and you compare this with relational database, you typically see a big advantage, big difference in the hardware consumption and what you need basically to make it work. The added value for you then is that this graph-based solution platform basically enables upsell, cross-sell. It enables you to find patterns within the data. You can detect anomalies and so on and so on. You can drive what-if analysis, right? So if we drill down now first into fraud detections, what is the impact of fraud? I mean, you have seen already on the right-hand side the insurance and a good example of it, but that's not only it, right? If you see banking fraud, and this is a research basically from 2015, and as far as I understand, it has not got better from there, right? It only gets worse. And in 2015, in America, in the US alone, banking fraud was worth something like 16 billion, e-commerce was worth 32 billion, and insurance around 80 billion. So we are talking here really about big money, right? And who are today's fraudsters, right? It's not so easy anymore, right? I mean, the fraudsters, first of all, they are organized in groups. It's most of the times not just one individual you need to find out. They use synthetic identities. What does that mean? Then they use identities which are basically constructed of real things. So you might have a real address, a real telephone number, a real social security number, but the combination doesn't work, right? And fraudsters are taking advantage of it. Fraudsters are also stealing your identities, basically, and fraudsters may also hijack your device, right? So if we now look at what Gartner Group said for fraud, right? I think this is very true, and you need to really see that and act on it, right? What Gartner said, basically 2015, is don't consider traditional technology adequate to keep up with criminal trends. What does that mean? That means basically that the fraudsters are most of the times better than you, right? And they are leading it to you. So you need to have the technology basically to keep up and detect the innovation they brought into the game, right? And what you need for that is basically a platform and also the technology to be quick and to act accordingly. Traditional fraud detection methods on this, on the other side, what they do is basically they have three different goals. One is endpoint-centric, so you take advantage or you look into the PC, you look into a smartphone, whatsoever. They are navigation-centric, so it's basically analyzing the navigation behavior and suspicious patterns. And they are account-centric, so they know what an account typically does, and they find anomalies there, right? So that's all not bad, right? That also already helps to detect fraud, no question, right? But what it can't do basically is that you can't with these methods basically detect fraud rings. You can't detect fake IP addresses, right? Because you are just looking at an IP. How would you find out that this is fake? It can't detect hijacked devices. It can't detect synthetic identities, right? Because all it does is just discrete analysis on what you have, right? And if you look at this slide, basically what these traditional methods are doing is basically you have a corridor of normal behavior, right? Let's take credit card as an example, right? If you take credit card transactions, what this corridor typically is that you define for an individual that they typically take their credit card for transactions worth up to, let's say, 200 euros or so, right? And if now something is out of this corridor, let's say somebody took the first time his credit card and he purchases something for 500 or 5,000 or whatever, right? Then the red alarm rings, right? And then you say, okay, this is outside the normal behavior. Let's look into it whether this is fraud, right? Nothing wrong with it, right? It does its purpose, it fulfills its purpose. But what it doesn't do, basically, is then looking at patterns within these normal behaviors, right? So if you declare and you say transactions under $100 or under 100 euros as an example, this is fine for this specific user for this specific account. If you do 20 of them, right, it sums up, of course, right? And you cannot detect this with these traditional technologies. So what you then need to do is basically to investigate all these patterns across the channels, across multiple channels. You need to link the entities together, and then you have a chance to really detect the stuff, right? And this is the connected analysis, and no surprise, this takes advantage of the connected data. So if you want to prevent fraud rather than just detect it, right, you need to have basically the knowledge about the connected data. You need to know how networks of people, how they are connected, to detect the fraud ring, as an example, to detect how they are peering together. You also need to be able to analyze or see the connections between processes and transactions, and also about ownerships. That's what you have seen in the first presentation for Panama Papers, right, and for Paradise Papers. There it was about ownerships, finding out if somebody does anti-money laundering, if somebody does tax fraud, and so on. And then, of course, what helps you, if you have the data model for it, is the power of Cypher, right? Because Cypher really helps you there to find unlimited connections between all kind of nodes, right? And all kind of entities of your data. So as one example, what we have done, and one customer we have worked with, this is about top-tier electronic payment services, and there it's about anti-money laundering, right? So they got basically from the regulations, they got the task, hey, you need to give us reports, you need to show us basically who is doing anti-money laundering and who is using your system to do something. So what this is about, as just one example, working with these guys, is if there is a group of people, let's say here in Berlin, around the main central station, right, and they are sending basically transaction worth 20 euros, 50 euros or so to another group you define in Colombia or so, right? The 20 euros itself is not the problem, right? But if you then see that these are hundreds of people basically bringing in this 20 euros in Berlin, and another 100 people in Colombia owning the money, and it's about millions, right? Then you may find out that this is about money for drugs, whatever, right? And this is really what they needed to comply. So the regulator basically forced them to give them reports. And they have not been able to do that and to fulfill these requirements with SQL, right? And now they are able to do that with Neo4j. What about machine learning? You heard this already in the first presentation. So what I think happens here is that Neo4j is a great enabler technology for machine learning. Why is that? Because with Neo4j you can automatically detect fraud patterns via Cypher. You can detect that. And you can then also automatically learn from it, right? And basically then also add additional connections. You can use the graph algorithms. You can detect paths, detect shortest path, and so on and so on. And your application, which should be then basically able to learn from it, right, can use the database because also of its speed requirement, of its intuitiveness, and everything like that, to learn from it and build this into the data model. Why is Graph superior for fraud detection compared with traditional approaches? I mean, first of all, it's straightforward that if you want to find connected patterns over an unlimited amount of hops, you're in trouble with relational databases, right? Because I guess most of us here in the room know that if you use a relational database and you have a join over, let's say, 3, 5, 10 tables, 20 tables or so, it's not easy. It's a challenge, right? And for relational technologies, then you very soon reach basically the end of the performance. And what you need to do then is use kind of optimization techniques like building aggregates, building all kind of things, which then basically are counterproductive for what you really want to do, right? Because you want to be close to detecting really if something is wrong in your data, right? Versus on Neo4j, you can traverse over the data. You can have millions of traversals per core per second, right? So that is not a limiting factor anymore. You can, in real time, act basically on incoming events in all changes for potential frauds, right? I mean, if you have access to third-party data or so, with Neo4j, it's relatively easy to connect this third-party data, right? In relational technologies, if you have a schema definition, if you need to change your schema, if you need to do something, it's a lot of work, right? I'm not saying you can't do it, but it's a lot of work, right? And it adds a lot of delays. It basically makes your project a lot more complicated. Time to deployment, right? I mean, you have heard it from the experience from Daimler as an example. Time to deployment there was relatively quick, right? I mean, as he said, it is not only about Neo4j, about the database, which was the smallest factor in it, but it is typically what we see. It's from weeks to months if you drill it down to the database, right, to Neo4j. Rather than if you look into relational techniques, you most of the times have a lot longer project cycles. Why is that? All of us know if you have a discussion about an enterprise data model and you need to have all the people there really to conclude on an enterprise data model, to find all the tables, all the schema, everything like that, so that everybody is happy with it. That takes time, right? And as soon as you have that, you don't want to change it anymore, right? You better stick to it, right? And therefore, the time to deployment, of course, increases by far, right? So the bottom line basically is that with traditional approaches, you have long cycles, right? It's mainly ineffective and expensive, versus on Neo4j, it's easy, fast, and affordable. How does Neo4j fit into your environment, right? I mean, if you look at traditional approaches with relational databases, and then you base basically your fraud detection, your data scientists on relational databases, this is, as we said before, and as we kind of concluded, right? I mean, this is good for discrete analysis, but you still don't have a holistic view of data relationship. You still suffer slow query speed for connections, right? What the next step and the next evolution for it might be that you say, okay, I mean, it doesn't work on the relational database, let's build a big data lake. Let's bring everything to this big data lake, and then let's try it there, right? Good for MapReduce, it's good for analytical workloads, but still you don't have a holistic view, right? And you don't have operational workloads, and it still takes weeks to months to process the data, right? So what I would then suggest is basically take the relevant data and bring this into Neo4j, right? Because with Neo4j, then you can power a 360 view on transactions in real time, right? And what you can do then is, if you see the connection upwards, basically to your application, that you see that you can take sense out of the transaction stream as it comes, right? No need to build up a big data lake, no need to batch process, anything like that. And then you can also respond and alert in real time and make notifications. And as an example, also cancel transactions, cancel a credit card or something like that, right? Parts of it runs in memory, yes. I mean, there is the perm space. Jim, do you talk about this aspect? What runs in memory? No. Let's take it offline. Yeah. And in Neo4j, then you can have a data set, use it basically to explore new insights and take advantage of its connections and look into it more into detail. If we then look at a potential architecture, how could that look like? I mean, here is basically something I came up with, like a, it's an example basically, right? So if you see in the middle here, we have a Neo4j database cluster, and on this database cluster, on the blue side, that's this one, you would have your fraud detection algorithms. This would be the algorithms which are constantly basically running against the database, right? With the stored procedures, with the APOC, you have the ability, they could also run in the fraud detection algorithms, no doubt, but there you have the possibility basically to structure your data, do insights, and do something on the data. And then upwards, basically, you can build a management dashboard, you can build fraud reports, real-time alerts, and so on and so on. So all the user interface basically can be built, taking advantage of Neo4j, going through the Neo4j Bolt driver. it's not isolated, right? So you need to have a connection to your transactional data and to all the data which is in your environment, right? And two techniques here shown basically on this architecture side. So first of all, you may want to ingest your data in batch, right? Just to fill it up, to be able who the customers are, whatever data you need basically to ingest. But then there's also a real-time component, right? The real-time component, bring in the transaction data, the credit card transaction, the bank transaction, whatever they might be, and then bringing this into Neo4j and the database cluster, and also backwards, right? The stream backwards. So in other words, if you have detected fraud or something, you may want to feed this also into your CRM system as an example, right? To take advantage of it. Again, this is just an example. This is something you can think about it, we can discuss, right? So if we summarize now, the benefits of a fraud solution based on Neo4j, so it basically comes down to our typical and our unique value add. One of it being agility, so you can constantly catch up with fraudster techniques. That's what Gartner basically says and what Gartner recommends. It is enabled for future requirements, and the solution can be built iteratively, right? So you can use use case after use case. It's also intuitive, so you can enable fraud analysts to use the technology. That's also what we have seen from Generali before. The speed, you can traverse over an unlimited number of connections, basically, to detect complex connections. It leverages data connections, so you have a 360-degree customer view, and it's scalable, and then also the TCO and the ROI helps you, right? So if we now then drill into GDPR compliance for a second, as a second example how to build solutions with Neo4j. First of all, what is GDPR? I think all of you may know that, right? GDPR is the General Data Protection Regulation, and the intent of it, or the idea of it, is that the data is your data, right? You as a consumer have the right to know what data is available about you. You have the right to understand what they do with your data. You also have the right to be forgotten. If you say, I don't want you to have my data anymore, delete it, right? Actually, all of the companies out there, it was ratified in April 2016, and all of the companies need to comply to it. That is what is written down in May 2018, which is not that far away, right? What are the consequences if you don't apply to it? So fines amount to 4% of the global turnover, or 20 million, whatever is higher for each instance of breach. So it's big money, basically. And you see on the right-hand side that already a couple of companies have gone through that, right? So it is treated honest, basically, right? And then the second bullet point, it also is adding personal liability for officers in a company. So this is something which is obvious, which will be needed for all the European companies, or companies treating European data or data about Europeans. What is also quite interesting is that this also requires an online service to make it easy for customers, for you basically, to transfer your information to other providers. And as said before, the right to be forgotten. So this is quite serious, right? The key requirements, if you can answer all these questions, you're fine, right? So the key requirements are, what data do you have about me? So if I call any arbitrary company, I want to know, what data do you have about me? Where is my data stored? And how and when did you obtain the data, right? And then the second list of requirements is, why do you have the data? Tell me, it's my data. Why do you need that, right? Who has access, who in your company has access to the data? Do you have permission to use the data? For what purpose? And is the data secure, right? Do you really take care of my data? How does the data travel through your system? And does the data ever cross international borders? If you can answer, or if your company you're working for can answer all these companies, cool, right? Is there somebody? There's a lot to do, I guess, out there, right? Why would you now need graphs for answering these questions, right? in the end, it's very easy, right? It's about connected data and it's about visualization of it, right? So if you see this compared to, I could not bring up basically enterprise relationship schema or something, a logical data model, you would see basically nothing, right? Here you see what the data is about, where data is stored, and that really helps you as an organization to build up and to comply to the GDPR rules. But if we look at it a little bit more holistic, right, what is really needed is a metadata level on top of the data. So you have all your silos of information, you have all the information stored somewhere, but what you need is basically some level on top of it which enables you to really look into, hey, where in this, like marketing or CRM here, where is really the data, right, and what is it about? So in the end, some of it, not all of it, but some of it is really related to metadata management, right? And what you then need to have is basically, first of all, or the value add in metadata management provided for GDPR is about data modeling and definition. So what is the definition of data? How is it modeled? Also about data transformation. How is the data transformed in your organization? Consent management. Did your end customers ever say, yes, I want the data to be used? And what for? And which specific part of the data? And then also about entitlement, right? I mean, who is entitled to really use the data? So if we first drill into data modeling and definition, this is basically now, if you see on the top level, right, the enterprise ontology. This is what we are all familiar with, right? There's a customer, the customer has a phone, the customer has a name. So far, so good, right? But if you then go down basically to the application logical model, or even more to the physical model, physical schema, you see that this is getting a lot more complex, right? Because the data, the customer name basically then is stored on the physical schema, in a customer schema, which is part of a CRM schema, which is whatever, right? And you need to be able, if you think back the second slide of GDPR, you need to be able to answer the question, where is the data, right? And here's the answer to it, right? Data transformation. So the data is, of course, living somehow in your organization, right? And the data is transformed over various steps. If you see it here from a business view, in this example, the data is going from a billing system into a transactional system into an enterprise data warehouse. Right? I mean, that's easy to understand, right? But now if you go back into the technical view, into operational systems and integration middleware and enterprise data warehouse, you see here that this is a lot more complex, right? Because it is not just the billing system, right? The billing system in itself also has a data model, of course, and the data model in itself also has a schema, has data, has formats of data. And the same is true then for all kind of applications named here. Consent management, right? I mean, I just drew up here basically myself as a node, right? So if I gave the consent to a company to use me for whatever, for marketing purposes or so, that doesn't mean that everything from myself is basically available. And also then the question is, for what is that really needed, right? And if you look here as a simple example, it might be that I said, yeah, you can use my email, right, my secondary email for specific applications. And not only that, I might have said, but only for the next 12 months, right? And then it is not valid anymore, right? And then you may have 2, you may have 5, you may have 100 of different functions, different applications taking advantage of this email address. And then if you go from right through the circle here, the same might be true for my business mail address, for my phone number, for my address for sending me a letter or something, right? So in a nutshell, consent management is not just a binary thing, right? It is not that I say, yeah, I'm okay for you using my data, right? It's a lot more complex, and you see the complexity here. And the reason that you see the complexity here is because there are graphs right here, right? If I would express the same in a relational model, you may not be able to see it, right, anymore. Entitlement, right? If you look at entitlement, then it is also something where you need to be specific who is entitled to see what and what for, right? So if you see on the lower side here the resources, these resources might be a table, it might just be a column, right? It might be just a row of a table or something like that, right? But a user might be then able to see resource 1 because he belongs to group number 1 in this case, right? But he might be excluded for some other versions for it. Pretty complicated, and in the end, this is also an identity management issue, right? And also here, that's the beauty of the graphs, right? Because I think all of you understand immediately what the problem here is, right? All of you, some of you may not see the same issue if this would be kind of schema and kind of tables and columns and relationships. So in summary, graphs in metadata management and data governance, what are they good for? 4 things plus more, right? It's about data modeling and definition. It's about data transformation. It's about consent management, entitlement. The whole question of data lineage, of data movement, right? How does data move through all the systems? That's something where graphs can greatly help you and give you a benefit. So why is graph now superior for GDPR if you compare this with traditional approaches? I mean, if the task is basically to trace the data through enterprise systems, if you use traditional approaches, this ends in complex queries with hundreds of join tables, right? You don't want to have that, right? Versus in Neo4j, you can use a simple single query traversing through the enterprise system. So you simply traverse through all the connections, and that's by far easier, right? Preserve the integrity of data lineage, right? I mean, how your data travels and how your data moves through all the systems, right? If you use traditional approaches and you have broken data paths and lineage, especially with NoSQL databases, you have a problem, right? Because you cannot basically follow up anymore on the connections, right? Versus with Neo4j, it's a continuous unbroken data paths at all times, right? And then the same is true for the effort which is required to add new data and new systems, the time to deployment from weeks to months, for what you have seen before, months to years, right? It takes minutes to draw new data connections, right? So bottom line is, with Neo4j, you can establish there basically a system which is easy, fast, and affordable, right? If you have now the foundation, if you have basically the data management side of GDPR, what you also want to do is, of course, dashboard and visual reports, also building up on top what you have seen before, as an example with the last presentation with Datev, where you also have the way to visually see what is the data about and what can you do with it. And here's just an example, right? This might be a role-based dashboard, a subject view. What you see on the right-hand side is a personal data map, right? If I drill down now a bit, everybody understands what this is about, right? You have a user. The user has basically given consent for different systems, which then basically goes down to the usage, where the consent was given from, and so on, right? Then it's also about the data update. When was the data updated? When was this basically imported, exported, and so on and so on. And that's basically what you need if you want to answer all the 9 questions. Remember from the second slide, right? You want to be able to answer all the questions you have here on the slide, right? Where is the data coming from? What data do you have about me? Tell me what is there and who is entitled to do something. And then, of course, you can also add a management view on it, right? I mean, you can add here basically who accessed the data from what location. Also, one of the questions, how is the data basically going through different, is it ever crossing, is it ever crossing countries? Is it crossing different systems, and so on, right? And if you look here at a report you can have for this specific person, that would be a data lineage report, right? That would be a report showing you when has the data moved to another location, for what for, and who has done it, and so on, right? And that might be something you need to comply very soon with. Here's basically the full picture of it, but I think it's quite obvious, right? I mean, you can look at this, you can understand what this is about, and this is the value and this is the technology Graph gives you with, right, and empowers you with. If we now look also at an example architecture for GDPR, that's also something we came up with. In the end, it's analogous to what we have seen before in respect of the center of it would be the Neo4j database, where you have basically the connection to the leading system, to the operational system. And also there, right, I mean, you would have a batch import data ingest into the Neo4j so that you can start from it somehow, right? But not only that, you also need in real time basically have the loop from the Neo4j database into the real system. Why is that? Because if somebody says, as an example, I want my data to be forgotten, there needs to be basically the loop back to the leading system. And then, of course, on the top side of it, you have all the abilities to provide dashboards, to user interfaces, GDPR reports, and so on and so on. And they would basically live on a layer, basically accessing the data via the Neo4j boat driver, right? Data visualization, Neo4j browser, so that all the analysts, the GDPR subjects, and also the authority can access the data and can look into the data, right? That is basically it from this side, also for GDPR. What is the conclusion? I mean, one of the conclusions is, yes, graphs are everywhere. Why? Because it's about connected data. It's about knowing what your data is about. It's about intuitivity, speed, agility. And then the second conclusion is that solutions really need graphs, right? Because you can build better solutions using the graph. One other observation is, quoting Alan Lakin, failing to plan is planning to fail. In other words, you better start to plan for it, right? And who can help you? I mean, one of the organizations who can help you is my organization, right? So I'm leading the professional service team. So we can help you basically with best practices using building blocks, and you basically avoid reinventing the wheel. We can speed up development and deployment. So talk with us, right? We can fill in basically this this gap here. Of course, there are also partners. You see them out there, right? And they can also help you. So this is not an exclusive list. But one of the lessons learned we also see in all the projects is training and also understanding how you best use Neo4j is essential, right? Take advantage of it and don't reinvent the wheel. With that, I thank you all for your attention, and I wish you a wonderful day. Thank you.